Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good
Good
morning.
morning, sir.
Good morning.
Assalamu alaikum, sir.
Assalamu alaikum, sir.
Waalaikumsalam. Waalaikumsalam.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Good morning. So, is this screen visible?
Yes, sir.
Yes, sir.
So, this problem we have done yesterday, and you were supposed to solve this one. A can solve 80% of the problems and B can solve 90%. A problem is selected randomly. What is the probability that at least one of them can solve it? And second part, exactly one of them solves. So how many of you have solved it? Can you all hear me?
Yes, sir.
Yes, sir.
जी बताइए कितने लोगों ने इस प्रॉब्लम को सॉल्व किया कल आई टोल्ड यू दैट यू अटेम्प्ट दिस प्रॉब्लम not only attempt I have solved it in the previous session with I am a group, so there is no question of attempting, means you must have the solution of this problem with you. Yes, should I
Sir,
start asking by name?
sir, I attempted.
Okay, Vanshika, who else?
I completed the first part.
Okay. Ahmad Said. Saeed, have you done? Can you hear me, Ahmad Said?
Yes, sir.
जी बताइए क्या स्टेटस है इस प्रॉब्लम का. Just
Sir,
yes, quick.
sir, I am unable to get that. My network has lost at last time yesterday.
Means what? नेटवर्क लॉस होने से क्या मतलब हुआ?
Sir, I
Jaldi
have disconnected from the class.
then what happened? And you remained disconnected throughout the day till this time?
No, sir.
नहीं तो आप ये वैसे अगर कनेक्टेड होते तो क्या करते, प्रॉब्लम कैसे सॉल्व करते? ये प्रॉब्लम आपके पास है या नहीं? अगर कनेक्टेड भी होते तो देन व्हाट वाज, आई मीन, यू मस्ट हैव ए प्रॉब्लम विद यू ना, तभी तो आप सॉल्व करेंगे, कनेक्टेड हो या ना हो.
Yes, sir.
तब इससे पहले वाली क्लास में थे आप,
Yes, sir. I was there.
तो इट वाज सॉल्व देयर आल्सो.
Yes, sir. I have my network was disconnected
Oh, I am
at
asking
last time.
about the previous session when we have engaged this session with IMA group.
Yes, sir.
तब थे आप क्लास में?
No, sir.
क्यों?
Sir, I was in yesterday's class.
What about the previous session? For the same for the same topic, you are not even aware, I think, that there was a previous session also for the same topic.
Sir, I am aware of that.
So you did not attend it.
Sir, I have attended that session. Yes.
So that problem was solved during those two sessions also. है आपके पास? I'm calling one by one and find out your status, and then you may leave the class one by one. If you have not done anything, if you are not serious, it's general instruction for everyone. If you are just logging in uh, for your online presence, that's all, then I will not allow you. You must have with you your calculator, your copy, everything. I mean, this screen is just like a whiteboard or blackboard in the classroom. So you have to note down something. You can click picture. You can, I mean, you have to do these things. If you are not interested, you may not be allowed. This is your first semester. If this is your seriousness, how will you do these remaining 3 semesters? Anam Rizwan,
Yes, sir.
what is your status about
So,
this problem?
sir, I attended the previous sessions as well. So, but the previous sessions, to be honest, for me, were like I was not able to understand. I'm not
Okay,
from mathematics background.
this one, yesterday, have you
So
attended?
I was able to understand the concepts, but I was not able to apply it. So I have this problem with numbers,
Have
but
you
I'll
attempted?
inshallah try to. Yes,
My
I.
question is, have you attempted?
So I tried. Yes, sir. I tried applying the concepts that you told me yesterday, like told us yesterday.
Arma? Arma Bano.
Yes, sir.
Hmm.
Yes, sir. I went through the question
Hmm.
and I tried to apply it as far with a little effort because I haven't studied maths after high school. After a little effort and with a little help from my classmates, I came to the answer of 1 second, sir.
Okay. I will coming back to you. Arusa?
Okay, sir.
Arusa? Arusa, are you there? Arusa is not with us. She has lost the connection or she has left the meeting. She is here. Yes. Asaba?
Yes, sir. Sir, I've also tried it, but I don't know whether my answer is correct or not.
वो कोई बात नहीं. आशुतोष?
Yes, sir. Sir, I have tried
What
the
is your
first.
statement?
I have tried the first part. I
Hmm.
have calculated the one in which it was asked that at least one of them can solve it.
Okay. Okay. Azizur Rahman. Azizur Rahman, are you there? I'm noting down these numbers as well. Those Pfizer
Sir, I haven't attended previous sessions.
yesterday.
Yes, sir.
You have not attended yesterday?
Yes, sir, I haven't attended.
Hamad,
Yes,
Hamad.
sir.
Hmm.
Sir, I attended the yesterday's session and I can solve the question, yes, sir.
Hmm. Sorry.
Sir, I am able to solve the questions.
Okay. Hamad Tariq.
Yes, sir.
Sir, I have not attended the last session.
And the previous one, on the same topic, we had another session with IMA group.
Sir, I attended that, sir, but
That was.
not able to sir, reply that. Unable to solve, sir, but tried.
So you have problem with you?
Sorry, sir.
Do you have the problem statement with you,
Yes, I have. Sir.
Imran? इमरान
Yes, sir. Yes, sir.
जी बताइए.
Sorry, sir. I am not attending previous session, but I try to at this time solve this problem. So please give 5 minutes.
5 मिनट्स अभी चाहिए आपको?
Yes, sir. Because of I am not attending previous session.
अच्छा, मदिया.
Yes, sir, I tried to attempt, but I'm not sure if the answer is correct or not.
Okay, no problem. You have the problem with you?
Yes, sir.
Aman, Muhammad Aman.
Yes, sir. I tried but not able to get, sir.
Saad,
Yes, sir.
what is your status?
So I'm trying to solve as I was not present yesterday.
Sayyid Ahmed Muaz.
Yes, sir. I did try solving.
Hmm. Usman Ali.
Yes, sir, I tried.
So did you get some answer?
Yes, sir.
Varesha?
Yes, sir, I have done this.
Okay, good. So anyway, I will repeat whatever you have done in your previous session earlier, but I will remind you that if you do not take notes, if you do not solve, if you do not practice problems, then you will be in trouble because we will be evaluating you throughout out of 70 marks for your internal assessment and 30 marks for the end semester examination. And I mean, that 70 marks means everything included your class participation, your assignment, which will be giving you, and there will be viva also. All these things together will contribute to your internal assessment out of 70 marks. So it's up to you. एक तरफ से ये आसान भी है 70 का इंटरनल असेसमेंट, but at the same time, if you are losing marks on that, it will be a great loss to you as far as grading is concerned, because you will be left with 30 marks only for end semester examination. So you have to be careful, attend classes, note down yourself, don't wait for material and PPT and all these things. You must have some book with you, either on net or textbook, hard copy. Wherever you are living, these things are available. So now this is how this problem will be solved. Those who have attempted, they can check at least one of them solves, or we can also ask for this like this: the problem is solved, or this statement may be rewritten as either of the two solves. So all these three mean the same thing. It will be calculated in the same way. If the question asks like this, at least one of them solves, or the question asks like this, the problem is solved, or the question asks like this, either of the two solves. So it will be same probability of A or B, and this formula, and you can find out this answer because PA you know, PB you know, and P intersection B both can solve is PA multiplied by PB, means zero point 0.8 into 0.9, 0.72. So this component will be 0.72. So you can find out this probability.
So, whenever at least in such situations are given where at least one of the thing is required, we use union, right?
Yes.
And in case of exactly one, also we use union.
But a different way. You can see here some microphone is on who is not speaking, but we are getting some disturbing sound. So the second one is exactly one of them solve it. Exactly one of them solve it means if A solves, B does not, or B solves, A does not. Exactly one of them. So it is again or here between these two. So one situation may be that A solves and B does not, or another situation may be B solves, A does not. So in any case, if there is or in between, then that means union. So you can see the union sign here, but it will be like this: A B C B complement plus B A complement minus this thing, and the values are worked out below. If you have any question, then please ask. Is this visible? The solution is visible.
Yes, sir.
Yes, sir.
Yes, sir.
So if you have any doubt, please ask.
So the first one can also be solved like one of them is solving three, like considering three situations where one of them is solving and other is not solving, like this.
You mean this one?
Yes, sir. First one.
1 minus p, none can solve it. Yes. So either you, solve this example like this or like this,
Okay, sir. Thank you.
as far as A part is concerned. For B part, the solution is with you. Whatever is the answer, then the next problem will be based on these sets of formula. So this you must have with you now in your notebook to solve
Yes, sir.
coming problem. Say, read this one. A parcel delivery firm is worried about the likelihood of strikes by some of its employees. The probability of a strike by the firm's pilots is estimated as 0.75, and that by the driver's 0.65. If the drivers strike, there is a 90% chance that the pilots will strike. Determine the probability of both groups striking and drivers striking given that pilots strike. So first try to note down these numbers using some symbols. So what is this 0.75? How will you write it in numbers? What is given, what is not?
So probability of pilots or probability of P we can write as 0.75.
Means probability of, say, pilots strike. How much is this?
0.75.
0.75. The next probability is
Driver strike. PS.
Driver's strike is
0.65.
0.65. And what is this 90%? Probability of what?
I think DS union PS.
Not union. This is like
Intersection.
Conditional probability.
So conditional.
0.9. How much?
90.
90.
90.
So that is important. You should try to understand this. So the probability of strike by the firm's pilot is 0.75, by driver is 0.65. If the drivers strike, there is a 90% chance that the pilots will strike. So probability of pilot striking given that drivers are on strike is 90%. Is this clear?
Yes, sir. Yes, sir.
So your first part which you need to calculate is determine the probability of both groups striking. Means probability of,
So PS union DS.
yes,
Yes, sir. Union.
not union, and
Second.
Intersection.
intersection, and which is simply what? PS and PS is,
DS in probability of DS into probability of PS.
yes, into probability of PS. So now, but in this case, हम इसको करेंगे कैसे? It will be when you rewrite, because this we will be using this 0.95 here. It is a conditional case. आप इसको नहीं मल्टीप्लाई कर सकते सीधे सीधे 0.75 and 0.65 को नहीं मल्टीप्लाई करेंगे यहाँ पे. Understand? Because this is a case of conditional probability. So here we will write probability of PS given that ds, okay, multiply by probability of ds means 0.90 into 0.65. This one. Like this. So, ठीक है?
Yes, sir.
So it is 0.90 into 0.65. Your answer is
0.585.
0.58.
Correct. And the second part will be, what is the second part? Drivers striking given that the pilots strike. means
So this is also a conditional case.
yes,
ds by dt.
this you have to calculate. So that will be simply probability of this joint probability which you have calculated, and PS divided by yes. Again, we are rewriting the same equation. We are rewriting like this. This time we are interested in finding out this one. So therefore, so 0.85, this you have already got as 0.85, and this PS is 0.75.
0.65.
Point
0.75. 0.75.
0.75.
So that will be your 0.7.
0.78.
Yes, 0.78 will be your answer. So as I told you yesterday, now I will be disconnecting for say 5 to 10 minutes because I have to
Okay, sir.
No problem, sir. You can go ahead.
सर गए क्या?
नहीं भाई, आएंगे अभी सर।
शायद क्वेश्चन ढूंढने गए हैं सर।
So hello,
Yes, sir. You're audible.
I'm back, and screen is visible.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So now we come. So that you got the answer to this part A and part B.
Yes, sir.
Now we are coming to another problem which is based on Bayes theorem. You can see Bayes theorem, which is an extension of conditional probability, but in some other situation. Look at this problem, then we will understand how is this different from a simple conditional probability. Two suppliers S1 and S2 supply a machine part to a manufacturer of a machine tool. S1 supplies 70% of the requirements and the rest is supplied. Rest means 30% components are supplied by supplier S2. Historically, 95% of S1's supplies are good. And how much defective?
5%.
5%.
5%, sir.
5%.
Whereas S2 supplies acceptable 90% of the time and 10% of the time it is defective.
Yes, sir.
One day what happened that a machine breaks owing to a defective part supplied by either of the two. It was not known. Now, given the information that the part is defective because there was a breakdown in the machine and we know that this breakdown was due to some component, some machine part. It was not known whether the machine part was supplied by S1 or S2. So the problem here is what is the probability? We would like to know what is the probability that the part was supplied by supplier S1. So the left hand side, first try to understand how will you translate this problem into symbolic form, means the left hand side. What do you want to calculate? Probability that the part was supplied by S1 given that the part
It
is.
is defective.
That is defective.
So it's the other way around, means the result is known. We wanted to know the cause. डिफेक्टिव है, ब्रेकडाउन हो चुका है, अब हम ये पता करना चाहते हैं कि इसकी सोर्स क्या थी. इन सिंपल प्रॉब्लम्स we often determine the probability that what is the probability that it was defective given by it was supplied by S1, for example. Here we wanted to know what is the probability it was supplied by S1 once we know that it is defective. So this is how we mathematically we calculate it like this. So in there is one numerator and denominator. In numerator we have this thing. Try to understand how to remember how to understand this formula. Once you write it correctly, the left hand side, then the things become easy. Probability of that the part is supplied by S1 given that it is defective. So you start writing right hand side from here, PS1 multiplied by P of D. But because this is a conditional case, therefore only D will not appear, but it will be D given that it was supplied by S1. So ये numerator आपका complete हो गया. I repeat, probability of S1 multiplied by probability of D, but conditional probability of D. That means like this. Then in denominator, this will repeat. Plus similar expression for supplier S2. Similar expression for supplier S2. So it's easy to...
So just a question, these S2 are the unfavorable condition, right, sir?
Sorry?
These
Yes.
You have put PS2, this one is the unfavorable condition.
Yes. So that is your second component of denominator. Had it been third supplier also, so numerator was same, but you will add third component of this type for supplier 3 and so on. And if you want to find out S2 here like this, sorry, then what will be the change?
So PS2
Sir,
into
PS2.
Change
The
will be in the
numerator it will be
numerator.
PS2 and the
And
denominator will remain same.
denominator be PS2.
And this will
S2.
remain same because this
Yes, sir.
one and this one. So this is how we solve an example on Bayes theorem. And how will you identify? You can identify from the information given, the way the information is given, what do you want to calculate. So it must be now easy for you how to write this expression. You don't have to memorize like that, but if you understand, then you can write it. It may be three suppliers, two suppliers. So any number of suppliers, it may be for S2, S3, or S1. Okay. So now, what is the information given? PS1. How much is PS1?
70%, sir.
70.5.
0.7.
PS2
0.7.
70. And PDS1. Defective when it is supplied by S1.
S1. Yes, sir.
0.05.
5% because
5%.
5%.
historically
It is
95% of the supplies are good. So 5% are bad. Similarly, PDS2 is 0.10. And these are the four things which are required in this expression. You can calculate this probability, which comes out to be 53.4 or say 54%. Now, how do you understand, how do you interpret that if given all this information, if machine breaks down and we wanted to know what is the probability that the defective part was supplied by S1, so you can see around 54% is the probability that the part was supplied by supplier S1. Of course, we are not solving many problems here. I'm trying to solve one or two of each type, and rest you should practice. We will also give you some problems to solve as part of your assignment as well. And as I told you, you should practice problems either from net, from book, online, offline, whatever is available to you, because uh, we cannot have all problems solved here. Now coming to probability distributions. Coming to probability distribution, a listing of all the probabilities. This
Uh,
also
sir, may I ask a question? So actually, I did not study mathematics or probability, so I had a query. So whether A union B and B union A are same things or are they different?
same thing, because there in that case you will write probability of B plus probability of A minus probability of B intersection A. Only the sequence of alphabets will change, A and B, B and A. Otherwise, it will be in the same thing.
Okay, sir.
Look here. So either it is B or it is A. B union A is also this part and this part. And A union B is also
This part.
either this or this. So by probability distribution, we mean a listing of probabilities associated with all outcomes of an experiment. For example, tossing a fair coin twice, possible outcomes. Say we are interested in number of tails. So how many tails are possible as a result of tossing a coin twice?
2, sir.
So 0, 1, and 2.
0,
Yes.
1, and
0, 1,
0,
and
1, and
you can
yes,
see
sir.
here 0, 1, 2. This is the condition of 0, means no tail.
Yes, sir.
This is one tail, one tail and two tails. So either zero tail or one tail or two tails. So if X represents occurrence of tail, then X can assume three values only. Hmm? If
Yes,
X
sir.
if
Yes,
X
sir.
if X represents occurrence of tail as a result of twice, I mean tossing a coin twice, then X can assume now X is a random variable. We call this as a random variable, and in this case, this random variable is occurrence of tail, and the numbers or the values which X can assume 0, no tail, one tail, or two tail. Now the probabilities associated with these outcomes. What is the probability of zero tail?
0.25.
0.25.
0.25.
What is the probability of one tail?
0.5.
0.5.
0.5, because there are two such combinations, head and tail and head. So either this one or that one. When we say either, it means 0.25 plus 0.25. Either means union, or either or union, they are same thing. So one tail means either this or this.
Or this.
So 0.25 plus 0.25,
0.25.
and there is no third component. ये वाला नहीं होगा, ठीक है, क्योंकि
Yes, sir.
दोनों चीजें नहीं हो रही. So therefore it is 0.5, and hello.
Yes, sir. You
Yes,
are
sir.
audible.
Yes, sir.
Okay, okay. So this is a simple explanation of probability distribution. Distribution of probabilities associated with different outcomes. So ये now, depending on whether a random variable is discrete or continuous. In this case, random variable is discrete. It will be either 0 or 1 or 2. It cannot be 0.5 or 1.25, 1.35 like this. Had X been not number of tails, but for example, number of, say, the percentage of marks, then it could have been a continuous variable. So depending on the nature of the random variable X, we use either discrete probability distribution or continuous probability distribution. There are many in each category, but we will be restricting to binomial and Poisson, two most popular discrete probability distribution, and one commonly used continuous probability distribution as normal distribution. So these are the characteristics of where do we apply binomial distribution? When the situation is like this, only two possible outcomes for each trial, the probability of success remains fixed over time. Here by success we mean the event or outcome of our interest. अगर हम head के occurrence की बात कर रहे हैं तो head का occurrence will be a success. अगर हम पास फेल में से पास होने की बात कर रहे हैं तो पास होना सक्सेस, और अगर हम फेल होने की प्रोबेबिलिटी निकालना चाहते हैं तो फेल होना सक्सेस होगा उसमें. So the probability of success remains fixed over time, and trials are statistically independent. We can understand this again with the help of this example of tossing a coin. If you toss a coin, there are only two possible outcomes, and the probability of success remains fixed. It probability of head or probability of tail remains fixed, and n trials are statistically independent. आपने देखा कि फर्स्ट ट्रायल के बाद सेकंड ट्रायल में probability of head or tail was same as in the first trial. Whether it was head or tail in the first trial has no effect on the probability of occurrence of head or tail in the second trial. So that is what we mean by trials are statistically independent. Any point which you need further explanation? Is this clear? Means where do we apply, what type of situation characteristics lead to binomial distribution?
Yes, sir.
Yes, sir.
Now mathematically, now we are coming to its mathematical part. This is how we write probability of r number of successes in n number of trials when the probability of success is small p. So this is how we write. I repeat, probability of r number of successes in n number of trials, given that probability of success is this small p. And this is how we calculate left hand side. Factorial n divided by factorial n minus r into factorial r, and whole multiplied by p raised to the power r multiplied by q raised to the power n minus r. What is q here?
Probability of fail.
Yes, it is 1 minus p, because there are only two possible outcomes. Agar p is the probability of success, then q becomes probability of failure, and which is nothing but 1 minus p, small p. The mean of a binomial distribution is given by n into p, and its variance is npq. And I believe that you are writing this formula with you.
Yes, sir.
That we will need for solving problems. Now let us look at this. For a binomial process with probability of success as 0.5, determine the probability of getting 8 successes in 20 trials. And then look at this second statement. For tossing a fair coin with probability of head as 0.5, determine the probability of getting 8 heads in 20 tosses. I will all these underlines. Look at the underlines. Tossing a fair coin is
Binomial process.
a binomial process. Head or tail, whatever. Here it is head. Represents
Success.
Success.
8 heads means 8 successes. And 20 trials means 20 tosses.
Process.
So this is how you should understand what are these numbers. And now you will write it like this. What is the probability of x? इसको r कर ले या r x कर ले, whatever. X equal r, 8, number of successes 8, n is 20, and small p is
0.50.
0.5. And then making use of this formula, we have calculated this probability as 0.1201. How will you explain now this number? Say 12%. It is 12.01. Say 12%. इसको statement में कैसे कहेंगे अब?
So the probability of getting 8 tosses, 8 heads in 20 trials is 12%. Like 8 अगर हम लोग 20 trials करेंगे तो 8 अगर heads मिलेंगे तो उसकी जो probability है वो 12% है.
Right. अगर हम 20 times toss करें और हम ये चाहें कि उस 20 times में से 8 head हो, तो इस बात की probability क्या है? है ना। एक बार आपने टॉस किया, हेड और टेल आया, दूसरी बार टॉस किया, फिर हेड और टेल आया, तीसरी बार किया, हेड और टेल आया। इस तरह से आप करते चले गए। अब जाहिर है 8 बार में कुछ नंबर ऑफ हेड्स होंगे, कुछ नंबर ऑफ टेल्स होंगे 20 टाइम्स में से। तो व्हाट इज द प्रोबेबिलिटी कि देयर विल बी 8 हेड्स आफ्टर 20 टॉसेस। इसकी प्रोबेबिलिटी 12% है। We were, we were, I mean, we have been through these last 2 years of COVID. And say, for example, there are situation if you have some symptoms and you are somebody's COVID positive. So what is the probability that the person will survive you? You must have seen in the second wave. What is the recovery rate? What is the probability of being recovered, or what is the probability of survival, or what is the probability of non-survival? All these things you can, because if there are just two situations, that if somebody is COVID positive, what is the probability that the person will survive or the person will recovery. So that probability, अब ये टेस्ट से आपको पता चला कि अगर 20 पेशेंट्स हैं फॉर एग्जांपल और रिकवरी की प्रोबेबिलिटी 80% है, if there are 20 patients who are found COVID positive and the probability of recovery is 80%, I'm talking, I mean, being an optimistic, optimistic, so probability of recovery is 80%. What is the probability कि उस 20 में से 8 लोग रिकवर होंगे? कितनी होगी वो प्रोबेबिलिटी?
सही 12%.
12%. So I'm just trying to, I mean, relate with some practical or application point of view, that if that is the case, if that is the data, then you can find out if there are 20 patients found COVID positive and the probability of survival uh, has been 80%, 0.8, then what is the probability of getting 8% recovered? It is 12%. So this way, I mean, we can relate to different situations, real life situations. Now, instead of using this formula, we can find out this value from the binomial table also. For example, this one. The probability is 0.5. Okay, 0.5, this is your p, small p. You can, this table is visible?
Yes, sir.
Yes, sir.
Small p, there are few values of small p: 5%, 10, 15, 20, 25, 30, 35, 40, 45, and 50%, up to 50%. And then we have n, small n values. I'm just showing one block for n equal 20 only, क्योंकि हमारे पास 20 की problem है. So 20, otherwise there are 4-5 pages of binomial distribution for different n values. And this is your x value or r value. So what you have calculated, x equal और r equal 8, ये n वाला तो है हमारे पास 20, इसमें 8, प्रोबेबिलिटी कितनी है हमारी स्मॉल p, ये 0.5. So your answer is
0.101.
Okay.
1 2, yes sir.
0. इसी तरह से इस प्रॉब्लम को भी, if you can recall, we have done this also. Spectrum Light Bulb Company went for mass production of bulbs, 4 different colors. 16 bulbs, 4 of each color, were packed in each of the boxes to be sold as a unit item. If 20% of the bulbs are estimated to be defective, what is the probability that a randomly chosen box contains at least 2 defective bulbs? देखिए, अब इसमें n कितना है? 16, because 4 different colors, 16 bulbs. Simply, so color is nothing to do with this defective or non-defective. It's just additional information. There are 16 bulbs. N is 16. Each color. Now, if 20% of bulbs are estimated to be defective, what is the probability randomly chosen box contains at least two defective? So at least two means
Sir, two or more than
Minimum
two.
two.
So minimum two.
two or more.
Minimum two, sir.
Yes, two or more. So two or more. When we have or, we add. What we add? Probability for r equal to plus probability of r equal 3 plus and so on up to, because there are 16, so last component will be probability of at r equals 16. You will add, this will remain same, 16 and 20 will remain same, but you will be adding these probabilities again, either from this, it is for 20, so you can't find out for 16 values from here, but now you have an idea how to use binomial distribution table, or you can use this formula. एक बार आप इसको यूज करेंगे r equals 2 के लिए, यहाँ पर r equals 2, this will be your 16 and this will be your 0.20. इस तरह से आप इसको r equal 2 के लिए करेंगे, 3 के लिए, 4 के लिए, up to 16, और we can do like this, 1 minus probability of r less than 2. यहाँ हमारी probability है r equal or greater than 2. अब क्योंकि प्रोबेबिलिटी, सारी प्रोबेबिलिटीज का सम 1 होता है, तो अगर 1 में से वो वाला पार्ट घटा दें वेयर r इज लेस देन 2, तो ये चीज लेफ्ट हैंड साइड, दिस इज सेम एज करेक्ट?
Yes, sir.
Yes, sir.
ये दोनों चीजें सेम है, या तो 2 और मोर और 1 में से लेस देन 2 कर देंगे तो ये दोनों चीज इक्वल हो जाएंगे. सो आइदर यू कैलकुलेट इट लाइक दिस और यू कैलकुलेट इट लाइक दिस. Any other question? Done? Now, Poisson distribution. This is also a discrete distribution, and you can see the characteristics. When do we use Poisson distribution? जब situation इस तरह की हो, we are talking about number of outcomes occurring during a given interval of time. How many patients are arriving per hour at a hospital? How many patients are arriving per 2 hours at a hospital? So that arrival time, this type of things represents a Poisson distribution. यहाँ the probability of occurrence of an outcome is proportional to the length of the interval. अगर आप नंबर ऑफ पेशेंट्स 1 घंटे की बात कर रहे हैं, नंबर ऑफ पेशेंट्स अराइवल 2 घंटे की बात कर रहे हैं, तो वो प्रोबेबिलिटी उसके अकॉर्डिंग्स में होगी, इज प्रोपोर्शनल टू द लेंथ. एंड सेकंड पॉइंट इज द नंबर ऑफ आउटकम्स इन इंटरवल is independent of the number of outcomes in any other interval of time. What is the probability of having, say, 8 customers or 8 patients in during, say, 10 to 11, 10 a.m. to 11? What is the probability of same number of customers from 1 to 2? एक ही घंटे की हम बात कर रहे हैं, सेम नंबर ऑफ पेशेंट की बात कर रहे हैं, लेकिन ये दोनों इंडिपेंडेंट हैं. इसकी प्रोबेबिलिटी का इसकी प्रोबेबिलिटी से कोई लिंक नहीं है. एंड हियर आल्सो these ट्रायल्स आर स्टैटिस्टिकली इंडिपेंडेंट. 10 और 11 के बीच में कितने लोग आने की प्रोबेबिलिटी थी, इससे किसी और दूसरे पीरियड में कितने लोगों की प्रोबेबिलिटी है उस पर कोई फर्क नहीं पड़ता। और एक और पॉइंट इसमें यह है कि in this case events either occur or do not occur. Again I repeat that if we are talking about arrival of 8 customers at a shop, for example, from 10 to 11 a.m. So either 8 customers arrive or do not arrive. ये नहीं कह सकते हम कि अच्छा 8 नहीं आए तो फिर 9 या 10 या 7 या 6. This we can't find out. We talk about either 8 customers arriving in an hour or not arriving, 8 not arriving. So we say events occur or do not occur. ये बाइनोमियल की तरह नहीं है कि अच्छा टोटल 15 थे, अगर 8 नहीं आएंगे तो कितने आएंगे. This we can't do. So here the mathematical part will be like this.
So just a query, can we say that it can be used to figure out the unpredictable situations?
To some extent, you are right. Yes. So lambda is average number of outcomes per unit time. Then this is the formula. Lambda raised to the power s multiply by exponential. ये वही log वाला e है, to the power minus lambda divided by. So it is log, not e is not a variable here. It is simply the base of log.
Log. Yes, sir.
So this is how. Now look at the example, try to understand, relate this formula. On an average, 4 persons per half an hour arrive at a vaccination center. What is the probability that there will be 6 persons arriving during 12 to 12:30 p.m.? So which interval we are talking about? What is the length of the interval?
30 minutes.
Half an hour, 30 minutes, yes, sir.
Half an hour, 30 minutes.
Half an hour. And 6 persons, half an hour. Means X is 6 in our case. And what is the average arrival rate for half an hour?
4 persons.
4 persons half an hour. So this will be your probability. If we make a minor change here, on an average 8 persons per hour arrive at a vaccination center. What is the probability that there will be 6 persons arriving during 12 noon to 12:30? Again, we are interested in 6 persons. And what is the segment of time, interval of time? Half an hour.
Half an hour.
But the average which is known to us is for
8
Per
people.
hour, 8%.
hour. So therefore, we will convert it into half hour. So therefore, average for half hour becomes 4. तो what we are doing कि हमारी यूनिट x की और लैम्डा की सेम होनी चाहिए. यहाँ हम 8 नहीं रख सकते इस 6 के साथ, क्योंकि lambda is given per hour and we are finding out probability of 6 customers per half an hour. So lambda also has to be in half an hour unit. So that will be the only change. Are we getting the point?
Yes, sir.
So this is how we can find out the probability, and its table will look like this. ये लैम्डा की वैल्यूज हैं. एक ब्लॉक होगा, फिर एक लैम्डा की वैल्यूज होंगी, फिर इसी तरह से दूसरा ब्लॉक होगा, नीचे तीसरा ब्लॉक होगा, और यहाँ x है. हमारा लैम्डा है 4. लैम्डा इज 4 and x is
6.
6. So x 6 and lambda 4. The answer is 0.10. 10.4% is the probability कि किसी इस आधे घंटे में, इस पर्टिकुलर आधे घंटे में 12 से 12:30 तक 6 लोगों के आने की प्रोबेबिलिटी 10% है या 10.5% है, अगर हिस्टोरिकली अराइवल रेट 4 persons पर हाफ एन आवर है. तो इस पर्टिकुलर हाफ एन आवर में 6 लोगों के आने की प्रोबेबिलिटी 10 है. ठीक है?
Yes, sir.
Yes, sir.
And then it could be again like this, at least 6 or more than 6 or at least 6, जैसे अभी बाइनोमियल में कर रहे थे। तो ये तो इट्स ए इनहेरेंट आई मीन पार्ट ऑफ प्रोबेबिलिटी कि अगर आपका इस तरह से है तो उसको कैसे जोड़ेंगे, या लेस देन है या इक्वल है या ग्रेटर देन है। सो दैट इज एप्लीकेबल हियर आल्सो। What is the probability? There will be at least 6, for example, at least 6% rising from 12 to 30. अब उसमें क्या चेंज होगा? At least 6% rising from 12 to 12:30. What will be the change? यहाँ क्या चेंज होगा?
More than 6 or equal to 6.
It will be greater than equal to
6.
एंड अब ये एक वैल्यू नहीं आएगी, फिर क्या करेंगे?
Sir, we will add the values of 6 and more than 6.
कहाँ तक? वो नहीं मालूम है इसमें।
Yes, sir.
Yes, sir.
There is no limit.
So here what will you
Yes,
do?
sir.
1 minus probability of x less than 6. क्योंकि less than 6 में we know 0 plus 1 plus 2 plus 3 plus 4 plus 5 बस। तो यहाँ हमें पता है, तो therefore if it is x greater than or equal to 6, then we can't have like binomial that x 6 plus 7 plus 8 up to n. यहाँ n नहीं है, तो इसलिए इसको हम 1 माइनस करेंगे। 1 माइनस प्रोबेबिलिटी x लेस देन 6। लेस देन 6 मीन्स प्रोबेबिलिटी x is 0 plus x is 1 plus 2 plus 3 plus 4 plus 5. So
probability of non-occurrence.
नहीं occurrence की बात। yes, 1 minus probability of non.
Excuse me, sir.
Yes.
Sir, can you please repeat this point? I didn't get it.
Say for example it is 6 or more in half an hour। ठीक है, इसको लिखेंगे कैसे? प्रोबेबिलिटी x इक्वल टू ग्रेटर देन
6.
अब इक्वल टू ग्रेटर देन 6 will mean what?
So we cannot find out the exact value that how many people will be visiting in half an hour. So what we will do, we will be just we will be proceeding with 1 minus the probability of non-occurrence.
Equal or greater. So equal or greater than 6 का मतलब ये हुआ कि 6 plus 7 plus 8 that we can't do, जैसे हमने यहाँ किया था r equal r 2 और more। तो यहाँ हम ऐसे नहीं कर सकते क्योंकि ये एंड पॉइंट हमको मालूम नहीं है। तो इसलिए हम इसको क्या करेंगे, हम इसको लिखेंगे 1 minus probability of x less than 6. That was all. So is your question answered?
Okay, sir. Yes, sir. Thank you so much, sir.
Okay, so we stop here for today. Then we will take up normal distribution in the next class.
Okay, sir. Thank you so much, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.